So I'm creating this little video in order to have us keep up with class. I want to start with our usual thing, our announcements, and see what we have here. So to make up for today's class, you're going to be watching this recorded lecture. I'm not going to create anything that checks that you have done so, but you are going to be obtaining some content for your lecture notes that you would not have received if you do not watch this lecture here. You're going to do the group activity of classification of matter, but this is not going to be turned in as a group activity. Each one of you is going to need to complete that. It will be due tomorrow night on January 17th. The homework that you will do is to do the skill building for classification of matter, and then be prepared to take the quiz that we were going to take in class today. This is the short quiz. It's just part of your class participation grade where you know the element names and their symbols. Let's make sure we put and symbols for the ones that I told you needed to commit to memory. And you had to read about mixtures, and you're going to bring those notes in and you're going to use those notes. So we will do that in class on Thursday rather than today. Now look further ahead. There is a module called Exam Information that you're going to need to work through. There's a lot of different things to read and watch and then complete, where you walk through how we use our devices to take our exams. That whole module will be due by the end of January 23rd. That will enable us to take our first real quiz, our content quiz, which is a 15-point quiz, on January 25th in class. That quiz, just so you know, will cover everything up through and including what we do in class on Tuesday. So that is what we will need to do to keep up. Now, we are working through classification, and I haven't talked about the elements yet, so we're going to back up here in your notes a little bit and cover the elements. You watched a lecture already on compounds that was already due. Compounds are subdivided into various ways, and one of the ways is how we will divide our units. We are covering inorganic chemistry right now. After our first exam, we will get into organic chemistry and then biochemistry. So let's talk about the elements. Elements can be divided into 3 different types of elements. This is one way to classify elements. The first one is metals. Now, metals are defined by the fact that they have these properties that are listed there in your notes. So I have space in your notes to fill in, and you can see what we have there as I walk through them. They're shiny. We see this image here of a shiny piece of metal. It's probably a piece of gold, big chunk of gold it looks like, but it reflects light. That's all shiny means. They're opaque. That means that light can't pass through them. You can't see through them. All metals are going to be opaque. Now that doesn't mean that if it is see-through that it is a non-metal, or that all non-metals are see-through, but we do know that all metals you cannot see through. They're malleable. Malleable means that if you hit it with a hammer, it would flatten instead of shatter. So that is how they shape metals sometimes, is to hammer them into a shape. They're ductile. Ductile means that you can grab it and slowly pull. Now, our hands can't do this, but machines can. And it can be pulled into a shape of a wire. That's how wires are made. They're not made by stamping them into or pouring them into a mold that's wire-shaped. You take a strong instrument that can grab it and pull, and slowly pull. And if it's warm, it's easier until it's pulled into the shape of whatever thickness of wire you want. And then lastly, they are conductive. They can conduct 2 things. They can conduct heat and they can conduct electricity. So those are your properties of your metals. The next category are your nonmetals. So if it's not a metal, maybe it's a nonmetal. So it's everything that a metal is not, all right? Non. They're not shiny. Now that doesn't mean it's not bright and pretty. This is not a shiny piece of yellow like the gold was, but it is, it doesn't have that same glisten that we have with our metals. Some are transparent, but not all. This is a piece of sulfur right here that we're looking at. This piece of sulfur is not transparent. You can't see through it, but some of them are. Clear is the word that we use for that. Clear doesn't mean colorless, it just means you can see through it. Most are brittle, means if you hit them with a hammer, they shatter into a bunch of pieces. They cannot be made into a wire. They're not ductile. Remember that word, ductile. They are not ductile. And they do not conduct heat. They do not conduct electricity. We would call them insulators. Insulators do not conduct heat or electricity. Now there is classification. There's not a whole lot. We see just a list of 7 of them here that are metalloids. Metalloids have some of the properties of metals and some of the properties of nonmetals. They might be shiny or have some kind of luster. This is a piece of silicon, and we can see it's really reflecting light pretty well. If I were to hit this thing with a hammer, however, it would shatter. This piece of silicon, and this is true for most of your metalloids, is they are what we call semiconductors. So it's not on the category of being a conductor or an insulator. It is a semiconductor, meaning at low temperatures, they behave more like your nonmetals. They don't conduct. But at high temperatures, they do conduct electricity. So that is what a semiconductor does. So these are your metalloids, your 7. Now, you're going to be on a periodic table like this one. And you need to be able to look at a periodic table and know where the metals are, the nonmetals are, and the metalloids. The way we do this is we find boron and draw a line under boron, and then we stair step down from there. The things that touch the stairs are your metalloids, except for one. You need to know that aluminum, think of aluminum foil, it is everything a metal should be. It is a metal. But everything else touching that is a metalloid. So we have our boron. Let's make that highlighted in yellow. Boron, silicon, germanium, arsenic, antimony. So you don't need to know a lot of those things, their names, but those are your metalloids. So then we have on the left-hand side, we've got our metals. And then we have on the right-hand side, our non-metals. Now, all of these guys right here are also metals. They actually fit right up into our periodic table right there. If we just squish those pieces right in the middle there. So they're all metals as well. So we don't have very many nonmetals. Most of our elements are metals, and then we have a very few metalloids. Now, we talked about atoms on our first day, I believe, of class. And at this point, we know the difference between elements. They are all made up of one atom, and then we have compounds, which are a mixture of 2 or more. So if they're made up of all the same atoms, they're elements. If they are a fixed ratio of 2 or more elements, let's say, for example, H2O. H2O is a fixed ratio. We have to have 2 hydrogens for every oxygen. Then that's a compound. But we need to define something called molecules. So here's the definition: collections of a relatively small number of atoms that are strongly bonded to each other. These molecules remain intact even when they're melted or when they're boiled. So this would be a molecule of water, a hydrogen atom connected to an oxygen atom connected to a hydrogen atom. That's a collection. It's a relatively small number of them all together bound, and they keep that connection even if I were to melt an ice cube, even if I were to boil water. Now, molecules don't necessarily have to be compounds. Here it is because it is a fixed ratio of two or more elements. But you can have a molecule that is made up of all the same atoms. So here is a molecule that is an element. The element chlorine is made up of diatomic molecules, two chlorine atoms connected to each other. So it fits the definition of a relatively small number of atoms. There are two of them there that are strongly bound to each other. So I have that little line connecting them there. And if I were to take chlorine gas and lower the temperature, I could turn it into liquid and then raise the temperature and be gas again. But in all cases, that connection that we see between the two chlorine atoms remain intact. So molecules are not necessarily compounds, though if they're compounds, they're very often made up of molecules. So here are some other examples. These would be elements. They're made up of the same atom. So two oxygen atoms held together, two nitrogen atoms held together. This one is also, so this one is also an element of phosphorus, four phosphorus atoms held together. But over here, these are molecules that are made up of different types of elements, so they are compounds. We have a carbon monoxide, a carbon dioxide, and water. They're compounds because they are a fixed ratio. For carbon monoxide, it has to be a 1-to-1 ratio. If it's carbon dioxide, it has to be a 1-to-2 ratio of carbon and oxygen. So these are two different compounds that have carbon and oxygen in them. So that makes them all compounds. All right, so you have got now an activity to work through, but it is not going to be as a group. You have to do it individually. Okay, you must go in and do it for yourself and upload it by tomorrow night. You'll find that activity under Tuesday's class in week 2, so it's there where it would be if we were having class. You're going to see an image like this in which you're going to take what you know about classification so far and see if you can fill this out. I bet you can fill out these right here based upon what we've talked about today. I know you can fill this one in based upon what we covered in the lecture that you needed to watch online for today's class. Now over here, it's not as clear for students when I think back on previous semesters. But if it's not a pure substance, it is a mixture. And here is where you will find your notes. There are 3 classifications of mixtures that I want you to find, okay? And see if you can find those 3 classifications and put them there in those boxes. The other thing that you are going to do with this classification of matter is you're going to come up with definitions of each of those boxes using your own words. Okay, so that is the group activity that you will do individually instead. Each one of you turning in one. I am fine with you talking. If you have friends in the class and talking together as you work through that, that's fine. But you do need to each one individually upload work for this assignment. Now I want to talk a little bit about an activity or a group of assignments that we will be doing in class. And that is we are going to be examining a caramel macchiato in detail. And we are going to do a whole series of activities. There is an activity posted. You can wait on doing this for after our next class. It was going to be assigned for your homework, but we'll wait till after next class. But you can start working on it if you want. And that is the first one that has to do with classification. It will have instructions on what to do with regard to that. Pull up the first caramel macchiato assignment. And if you want, you can go ahead and work on it and get it uploaded. But it will not be due yet. I want to give you a little bit more time. All right, so you've watched the little lecture that you needed to watch to make up for today's class, to make sure you've got all the information. Now make sure you go in and you complete the classification of matters group activity as an individual, the skill building for the classification of matter. Make sure you're prepared to take our little quiz at the beginning of class. This is a short, it shouldn't take you more than a few minutes, a short, I think it's 7-question quiz. And do not hesitate to send me an email if you have any questions. Remember, my email address is kim.woodrum@uky.edu.